Here is my 7th DER of my grade 11 year, the mechanical DER. In this DER, I chose to use a basic servo to create an RFID servo lock that can be used on cabinets. This specific servo lock has three major components: the Fusion 360 design, the RFID, and the code to run this project. Firstly, a Fusion 360 design must be created to benefit off of the servo's basic movements. In this case, three different components were created: the servo case consisting of a box on the top, the hook, and the latch. The servo case is a basic design, being a box that fits the servo with two stabilizers on the bottom, which can be used to mount the case to a wall using screws, and a small hole in the box to allow for the wires to fit through it. On the top of this case, there are two holes to be used to screw in the servo top, which is just a small rectangle used to hold the servo in place with screw holes in it. Next, a hook must be built. In my case, the design was similar to a Lego minifigure's hand and included a basic hole in the arm to allow for it to be mounted to the servo. Finally, the latch can be created, which is just a basic rectangle with a hole in the middle with two mounting holes on the bottom to fit the hook. Secondly, the RFID component in this build must be understood due to its massive impact on the project. For simplicity's sake, I will dumb it down a lot, but essentially RFID works using the same technology wireless chargers do. When the card in this case gets close to the module, a circuit is completed. The card then receives just enough power to send out a basic combination of numbers, being its card ID, through a sinusoidal-looking field that changes extremely little to signal a 0 or 1, creating binary numbers. The module then can pick up these numbers and spits them out using a bit of code. One thing that crossed my mind during this project was when I tried my student ID and was able to seamlessly open my lock with it. After diving deeper, I was able to find out how to clone chips. Unfortunately, as I did not buy clonable chips, I was unable to do so. With that being said, with an investment of $3 into China's chip market, I would be able to completely undercut the IT department. This can be done due to the lack of security within RFID, as with a simple brush past the teacher allowing for my module to read their IC chip, a lot could be accomplished. Not only could I undercut IT's $10 price for a new card, but I could sell one that has access to the school at all times, and could open the door to the science department, as only teachers have access to those functions under COVID protocols. Moving on, the code in this project was quite interesting, as using a basic example sketch was almost essential due to the difficulty in reading the chips without breaking them with short or other random errors. Despite a couple of complex functions which were built into the RFID library code, it is quite understandable, as the module waits for a card and once found it just reads the card's ID. From there on, it checks if it resembles any of the card IDs which I've given access to, and if it does, the green LED is turned on using port register control, and the servo is moved to the unlock position. On the other hand, if the card ID does not match with any of the card IDs that are granted, the red LED is turned on and the code ends.